Hi everyone, am I audible and is my screen visible? Okay, so hi. Um as usual, I am Geetika Agarwal. I'm a PhD scholar at CES in ISC Bangalore. I'll be taking this tutorial session today. This is for the 10th week of the course Wildlife Ecology, which is taken by Dr. Ankur Awadhiya on NPTEL. Okay, so in this week, as you all know, we have discussed the ecology of change, how changes in different things brought about by humans are affecting the ecosystem or the environment in general. So in the three lectures of this week, the things discussed were mostly oil spills, the impact of plastics in the on the marine life, and the impacts of climate change. So, what are the ways in which an oil spill can happen? And or like what is an oil spill and how does it happen? Can you guys tell me? What do we mean by an oil spill and what are the various ways in which an oil spill can happen? Okay, natural oil seeping into the seawater. Liquid oil spread on terrestrial or ocean. Yeah, that is the definition of an oil spill. When basically liquid petroleum oil gets spread or spilled on either land or in the ocean. And what are the various ways in which an oil spill can happen? Rajeshri has answered one saying that in a natural way, the oil can be seeping in the seawater. And what are the other ways in which? So, obviously, if one is natural, other would be an anthropogenic cause leading to oil spills. So, what are the two anthropogenic ways in which an oil spill can happen? Yeah, it is either accidentally done by a human or intentionally. So, these are the three ways in which oil spills can mostly happen or do mostly happen on Earth. So, I am going to be covering the accidental oil spills. And so, are you guys aware of how can oil get spilled into the ocean accidentally? Or like any scenario that you can think of where the oil can get spilled on in the ocean while shipping. Yes, very nice. It can either happen while shipping because mostly oil is not a resource that is uniformly available or across the globe, and but it is required uniformly by everybody living in all the nations and all the continents. So some nations they import their oil from other countries, and this import happens via shipping. So during that shipping an oil spill can happen if the tanker either overturns or it collides with an iceberg or some rock or some other tanker. So that is how an oil spill can happen. And correct, oil rigging is the another way in which an oil spill can happen. So oil rigging is basically when you are extracting oil from beneath the ocean bed. So I will now talk about two case studies. One in the case where the petroleum oil was actually spilled because of the tanker colliding with an iceberg. And the second is when the Deepwater Horizon oil spill, in which it happened while the oil was being extracted from the ocean bed. Okay, so I'm sorry for the animation. So the number one case study is of the Exxon Valdez oil spill, which happened in 1989. It was a major event which happened in the United States and it caused a lot of havoc in that region. So what was going on at the time was that there are these nations called the OPEC nations, which is the The full form is Organization of Petroleum Exporting Countries. So these countries, as you might guess, are mostly the countries found in Middle East, which is in Asia, the Saudi Arabia, Iran, Libya, and other countries in that area. Because you might know that these areas are rich in the petroleum oil resources, in the liquid oil resources. So USA used to import their oils from these OPEC nations earlier. But what happened is, when there was a war between the OPEC nations and Israel, USA took the side of Israel. And that is when the OPEC nations decided that we are not gonna export oil anymore to USA. And USA then faced a crisis. And yes, these are the OPEC nations. And then USA faced a crisis in which it was not able to fulfill its energy requirements. So, for that, they wanted to find out a new source of oil in which they would not have to depend on any other country for their energy requirements. So that is when President Nixon, they found out that there is an oil source in northern Alaska. So this is Alaska, which is also a part of the United States. And in the northern part here, they found that there is an oil resource. So this is the Prudhoe Bay. But it is very far off from the rest of the United States. So a pipeline was laid down between the Prudhoe Bay and the Valdez port. Prudhoe Bay is uh, on the northern shore of Alaska, and they built a pipeline from there to Valdez, which is on the southern port of Alaska. And from Valdez, a tanker would go and ship the oil to the rest of the United States. Okay, so as you can guess from the title, which is the Valdez oil spill, so what happened was that basically an oil tanker which was built by the Exxon shipping company, which was the name of the tanker was Exxon Valdez. So it spilled around 11 million gallons of crude oil into this Alaska's bay, which is the Prince William Sound. That area is called this this area right here. So here, the Exxon Valdez tanker, it spilled like millions of gallons of crude oil on March 24, 1989. And for this, so this is how it looked. So this was the Exxon tanker, and this is a rescue tanker which is taking off the rest of the oil that is still on the ship and has not spilled into the ocean. And this is how the ocean looks when it gets covered with a slick of oil. And later on, two reasons were found of why the oil got spilled into the ocean. One was that the company had failed to install the technology on how to locate an iceberg on the path of the ship, and that is why the ship collided with one. And the other one was that the captain of the ship was drunk when the ship left the Valdez port, which was a big reason. And the captain got like a fine of around $50,000 to pay for the consequences of this event. So the impacts were that a huge amount of marine life was like impacted. Around 300 seals, 250,000 seabirds, 250 eagles, and 22 whales. They were found dead. And as you know, this might have been because the seals or these whales, since they are sea mammals, they're marine mammals, they have to come ashore for taking in oxygen, right? So when the entire not the shore, sorry, they have to come to the surface. And when the entire surface is covered with huge amounts of oil, these seals or these whales, when they come to the surface, their entire body either gets covered with this oil slick, and they're unable to respirate, they're unable to breathe in. So that is how they die. And a lot of seabirds which dive into the ocean to capture fish, when they dive, their entire fur gets coated, their entire feathers get coated with the oil, and they're unable to thermoregulate, they're unable to survive after that. The entire coast got polluted, and the local people, they lost their livelihoods because they could not fish anymore. If there were a lot of fishers in that area, they could not do that anymore because these fish had gotten contaminated with oil. So they lost their livelihood for a lot of time. So the cleanup for this event, it took around 3 years after the spill. And the company, which is Exxon Valdez, it paid around $1 million for the cleanup. and it was fined another $2.2 billion by the court. And the locals were compensated from this money because they had just lost their livelihood. A fine of around $507 million was um, laid on the company for the other damages, and the captain was fined $5,000 for his inappropriate behavior. Consequently, the US Congress then decided that okay, we'll come up with an act so that this does not happen again. And that is when they set up the Oil Pollution Act of 1990. And here they have framed a lot of strategies for preventing and such oil spills, and for how to compensate if something like this happens, and what are the liabilities with this. So, this was all about the Exxon Valdez oil spill. And the other major oil spill that happened a few years later was the Deepwater Horizon oil spill. It happened recently, 10 years ago in 2010, 13 years ago to be precise. So, this is the Deepwater Horizon. This is how the spill looked like. So much water got spilled. So, it happened in the Gulf of Mexico region, which is around 41 miles away from the American coast. And this is the Deepwater Horizon oil rig. And it got exploded, and that is why the oil leaked into the ocean. So, starting with what is an oil rig? So, an oil rig or an oil platform. So, this is how the Deepwater Horizon oil rig looked like. And an oil rig is basically a structure which is used to extract oil from beneath the ocean bed, and it also extracts natural gases. And additionally, it contains facility to extract oil and to accommodate the workforce that lives here. Because obviously, if it's so far away from the coast, the workers cannot be transported every day to and from the oil rig, right? So they're supposed to stay on that structure. So what happened was in April. So basically, I'll give you a little background about the Deepwater Horizon oil rig. So it was built by Hyundai, and later on it was taken up by a company called Transocean, which then gave it to BP Oil, which is another company, and BP Oil at the time was using it to extract the oil from beneath the ocean beds. Okay, so on 20th April 2010, what happened was they were extracting oil from 13,000 feet underground, and then there was a failure of a blowout preventer, and a lot of methane gas got expelled out, which led to a huge explosion. Here, around 11 workers died on the spot, and 17 of them were injured, which must have been rescued later. And on like 2 days later, on 22nd April, this entire oil rig, this entire structure, it sank into the ocean, and that is when the oil that was stored in the rig, it started leaking into the ocean. And around, so it is believed, around 6,000 barrels of oil leaked per day into the Gulf of Mexico for the next 3 months. So you can imagine how big is a barrel, and huge quantities of oil got leaked into the ocean for the next 3 months constantly. So, moving on, what were the impacts of this explosion and of this oil leakage? So, as you would have guessed already, there was a oil slick on the water surface because obviously oil is lighter than water. It covers the entire surface. Again, the marine life was severely impacted. Around 6,000 birds, 609 sea turtles, dolphins, and other marine mammals were found dead because of this oil uh, spill. And the water was also contaminated with high amounts of these compounds, these hydrocarbons, and these are carcinogenic in nature. And that is how they impact the marine life. And also, if later this marine life is consumed by humans or like people who catch them, they also get impacted by these uh, carcinogenic compounds. So, moving on, who is supposed to take responsibility for this event? So in this image, you can see that the oil rig is on fire, and these other tankers have come and they're trying to uh, tame it down by using some fire extinguishing. And this is how the oil slick looked like when taken from a drone image. This is how bad the oil spill was. And so, who was supposed to take responsibility for this spilling? So basically, at that point, since BP Oil was using the oil rig, The court held that company responsible because there was negligence on their part. The staff was not trained on what to do when such event happens. If such an explosion happens, what are the safety measures to take? And they were fined with 18 billion dollars. Transocean, the company that had given it to BP Oil, it was also imposed a fine of $1.4 billion. Halliburton was the company that supplied cement for the building of this oil rig, and they were also held responsible because the cement they used would have been faulty, because that led to a leakage of oil and it was not sealed in properly in the rig. So they were also fined by 1.1 billion dollars. So these were two major oil spilling events that happened on like they were associated with the USA. There are many other oil spill events, but these are the two major ones that happened in the history, and they have had severe consequences on wildlife and on the local people of those particular areas. Any questions so far, or anything you would like to ask about either this or anything in general? If not, I'll move on.
No questions, ma'am.
Okay, so moving on. Now we're going to talk about plastics. So this was covered in the second lecture. And as you can see in this poster, you can go through this poster later in your free time. It mostly talks about how we've been using huge amounts of plastic because, as we discussed in the last class, there is a lot of consumerism, and we were trying to. All the metal is very expensive, and plastic is something that can be produced in huge amounts. It is inexpensive as compared to metals, and that is why it has been replacing metal for a long time now, and people have been using it for everything. So, anything around you will contain a little amount of plastic. So, in general, it is bad for the ocean, it is bad for us. A lot of plastic is getting spilled into the ocean all the time, and it's made of a lot of toxins. It also contains petroleum and natural gas, which either goes into the making of the plastic or it is one of the things that is used for making the plastics. So, moving on to how so this also tells you what you can do in order to help. But basically, one of the main things you can do is only use less plastic, because there is nothing else. Because anyway, if you don't dump it in the ocean, you're going to dump it in like landfills, and that is no better than dumping it into the ocean. So yeah, you can go through this poster later. Moving on, we're going to talk about the case study of the Great Pacific Garbage Patch. It is called this because so it's not really a patch like an island of garbage, and it cannot also be imaged using satellite imaging or anything like that. It does not look like a big patch of or a pile of garbage like you could see in major landfills. Like even if you've gone to Delhi or something, there are these huge mountains of garbage on the outskirts of the area. But here, so it's not really an island and it's not really like it looks here in this image. This is just a cartoon. But the Great Pacific Garbage Patch is basically composed of one huge patch which has like concentrated garbage uh, between the coast of USA, here in California, between California and Hawaii. So these are the Hawaiian Islands. So one garbage patch is located here, and the other one is off the coast of Japan. It's here, which is called the Western Garbage Patch, and these both are connected together by the subtropical convergence zone. So here, the North Pacific, it brings the cold water, and here the southern water comes, which is warmer than the Arctic waters, and there's a barrier here, like both these waters mix here, and there's this current motion, as you can see in these lines, sort of like a circular current. So garbage keeps traveling from like from as far as from the coast of Japan to from the subconvergence zone to here in the eastern patch and then back again. And in these localized areas also there are these circular ocean currents going on because of either the eddy currents and because of the wind patterns, so that these garbage areas, they have high concentrations. and they here the water is not very like the flow is not very heavy. It's a slow flowing water, and that is why the garbage gets concentrated in these areas. And this garbage patch is not only present in the Pacific Ocean, but also other areas like the Mediterranean Sea are also now coming up with these garbage patches because of the increased amount of disposal that is done by humans. But I'm taking this example of this very famous Great Pacific Garbage Patch. Moving on. So, how was the patch discovered? So, like, you would not come across this patch just like that, or you cannot even spot it in the satellite images, as I said. So what happened was, so this garbage patch, it was discovered by Charles Moore. This is Charles Moore, this person on this. So he was the captain of a racing boat, and after having a yacht racing competition, he was traveling from Hawaii to California. That is when his ship, it passed like, or his boat, it passed right from the middle of the garbage patch, and that is when they saw that, okay, on all sides of our boat there is just garbage, there is just plastic everywhere. So that is how they discovered the patch in 1997. And this person, he has this organization which is called the Algalita Marine Research Foundation, and through this organization he's still trying to spread more and more awareness about this garbage patch. And you would not believe it, but when they go on their regular surveys, so after around um, 30 40 years, or like right now, when they've gone to survey this area, what they saw is it has 100 times more plastic waste in those two garbage patches, in the one in the garbage patch in the eastern garbage patch, than it had in 1997. So moving on, around 70% of the marine debris actually sinks to the bottom of the ocean. So a lot of this, even though it stays afloat, but a lot of this also sinks down. It becomes heavier over time, or it breaks down over time and sinks down in the form of microplastics or something else. So here is again an image of this eastern garbage patch. This scale shows like the maximum amount of garbage to the least amount of garbage here, and this is how it looks like. This is also again a cartoon, but this is how it looks. 8% of it's microplastics, 13% mesoplastics, 26% macroplastics, and 53% of megaplastics. So you might be aware of like these different debris classifications of micro, meso, and macroplastics. Most of the debris comes from plastic bags, comes from bottle caps, comes from these disposable water bottles, comes from styrofoams, cups, and such things. Just give me a second, guys. I'll be back in 1 minute. I'll be back in 1 minute. यार तुम लोग प्लीज चिल्लाना बंद करोगे, मेरे कॉल इसमें आवाज आ रही है. Hi, yes. So yeah, I was talking about these plastic debris in the ocean. So in 2018, a study found out that mostly half of the mass of the Great Pacific Garbage Patch is composed of these fishing nets. And we'll come to this later, but you might be aware of how a lot of these fishing nests lead to ghost fishing, and how it is very, very harmful to the marine life that is out there. Okay, so why do plastics make up majority of the marine debris? So I was actually going to ask this to you, but okay, the slide animation did not work. So as you would be aware that plastic is famous, got famous among the humans. Why? Because it was durable. It lasted for a long amount of time, and it could not be degraded by any of the biological processes, right? So that is one way that made it durable, and like you could store water in it for a long amount of time, or you could use it for various things. You could make bags out of it, they would be waterproof and things like that. It costed less, it was less costly than other materials that you could use, which would deliver this much usage. And it was malleable, so you can make anything out of plastic. You can have toys, you can have plastic bags, you can have pens, you can have say bottles, you can have anything made out of plastic. So it is highly malleable. That is why it gained very It gained a lot of popularity among humans when they started using plastic. So, and also, as we discussed in the last class, there is huge amount of consumerism, and there is a lot of, like, industries have been churning out a lot of products for people to use. And since plastic is so inexpensive, most of these products are made up of plastics. And as I said, they're not biodegradable, but instead they get broken down into smaller pieces. So it's not that they stay in their huge sizes, and that makes one of the issues of when it comes to cleanup of this plastic waste from the oceans. As you can see in these images, so this is a lot of fishing net which would have been found in the garbage patch. These are some cups, these are other things, some caps, some bottles. All these things are found when you look at the plastic debris found in the oceans. So moving on to how a lot of marine animals, they die because of this plastic waste. So here you can see more than 90% of the seabirds, they they are found with plastic pieces in their stomachs. Why is that? That is because these seabirds, they dive into the ocean, like when they look at some small plastic object floating around, they think it's a fish, and they dive down and they consume it. But and they and if they keep consuming these plastic objects, they think that the stomach is full, but they're not really getting nutrition out of it because you cannot really process the plastic. And that is one of the reasons that leads to malnutrition and their consequent deaths. There are a lot of turtles that are found with plastic in them. Whales either have plastics in them, or they get caught in these nets. Dolphins, seals, all the marine animals that you can think of are getting impacted by plastic. There is no such marine animal that is like free of any plastic impact, or even for that case, even oil spills. It impacts everything. So, what are the various threats to marine life? So one of the major threats is faced by sea turtles. Sea turtles, they actually like to feed on jellyfishes. And you can imagine when they look at these floating plastic bags, they look like jellyfishes, and they would think that, okay, yeah, this is a jellyfish, and they would try and eat it. But as I discussed earlier, it would just accumulate inside of them and not really get processed and not really become or translate into any proteins or nutrition for this turtle. Coastal birds like albatross, as you can see in this image, so they feed on all of these bottle caps and all of these small plastic objects that from afar look like fishes, but they're not really fishes. And so they die of malnutrition. A lot of seals and other marine mammals that either get caught in the fishing nets, or they ingest all of this plastic thinking of it as some food or the other. And if their plastic is covering the surface, a lot of the phytoplanktons and algae are not able to get enough sunlight, and that in turn leads to lower biomass in the marine ecosystem. And if there's lower biomass, if there are lower amount of phytoplanktons, that's going to bring down all that's going to impact the entire food chain and bring down the amount of resources that is available for the other bigger marine animals that feed on these planktons and algae. And then we're going to be talking about what is ghost fishing. So you might be aware of this by now because it was discussed in the lecture. Ghost fishing basically happens, it's a term that's used when, okay, so mostly if the net is of no use any longer, maybe it's cut at some places, or maybe it's not as good a quality as it used to be. A lot of the times these fishers, they just throw it out of their boat, and it just sinks down or it stays floating in the ocean or something like that. And a lot of the marine animals get trapped in these abandoned fishing nets that were discarded into the ocean. And that is why it's called ghost fishing, because nobody is really fishing for these organisms anymore, but they're still getting caught. So you can see these images, these are some turtles, these are some fishes that are getting caught. This is a seal that would have gotten caught by a ghost net, and you can see how bad it got injured because of that net, because it just sometimes it's so sharp it just cuts through their skin, and they're even not able to escape these, and they get trapped. And as you know, these reptiles and these mammals, they're supposed to come to the surface for air, for breathing. If they get trapped in this net, they will not be able to swim to the surface, and they are possibly going to die, and they mostly die because of this. Okay, so coming to photo degradation. Can you guys tell me what is photo degradation? Finally, one slide in which the animation worked. So, okay, what is photo degradation? Anyone would like to take a guess?
Degradation of photo degradable molecule.
Hmm. So, okay, photodegradable is again, like you just used the term there, but yeah, okay. It makes sense. Photodegradation happens when sunlight acts on certain particles, and these particles get degraded by the action of the sunlight. So here, since we're talking about in the terms of plastics that get spread out on the ocean surface, so it's breaking down of macroplastics or mesoplastics into further smaller fragments, such as microplastics or micro debris, due to the action of sunlight, because it will like break down the bonds that are found between these hydrocarbons, right? And so during the process of photodegradation, a lot of these plastics, they leach out a lot of harmful chemicals. So, as was discussed in the lecture, a lot of these plastics, they are in them. You put these anti-flame particles so that they don't catch fire, and you also put a lot of these colorants so that they are brightly colored. They look pretty. That is why. So when these plastics they're being degraded because of sunlight, they lose a lot of these chemicals, and these chemicals can turn out to be carcinogenic, or they can in turn get accumulated in the bodies of bigger organisms, and they can lead to a lot of these health problems that they might be facing. And plastics, if they're leaching out these chemicals, they also can end up absorbing a lot of these harmful pollutants that might already be present in the seawater. But okay, so what is the issue if the plastic is absorbing the pollutants? The issue here is that if this plastic now gets consumed by mistake by some other sea organism, it the organism is not just gonna have the plastic now, it's gonna have the plastic which is laden with a lot of these toxic pollutants that were found in the seawater. Okay, so moving on. So how to clean up the patch or the Great Pacific Garbage Patch, or in general, how to clean up the plastic waste that's found in the marine environment? What do you think would be some ways in which you could clean it up? Or can you come up with some ideas in which you think you can clean up the patch of waste?
Recycling.
Recycling, that is true, but that is a preventive measure that you're talking about, that you basically don't throw the plastic away in the first place, and you instead you recycle it, right? But when there is plastic out there in the ocean, how do you think, or do you think, is it, can we clean it? If yes or no, if yes, how do you think can we clean it? Collecting those plastics in a mega scale by using ships. Okay, that is a good approach. You go out on ships and you try and collect all that plastic. But like, what do you use to collect that plastic? How do you collect the plastic? You do go on ships, but I don't think you're suggesting that people would then dive into the water and then pick up this plastics and bring it back up the ship, right? What what is how are you going to collect it?
We again have to use these nets to collect all this garbage floating on the ocean.
Yeah, right. So that is what like humans also thought that okay, fine, you will use with two ships in opposite sides. with a large collecting device. Okay, so you're talking about something like a. Okay, I understood what you're talking about. Something like a collecting object. Okay. And with floating structure, a system used by Greece. Okay. Can you elaborate more on these, Rajeshri? I think I would want to know what this system is. I am not aware of this system or like this floating structure. And what you said, Sai, is correct that okay, fine, you would think that okay, good. So you would think that okay, fine, we would collect this thing by again using fishing nets. But one problem there is all of these plastics are also the same size of a lot of these marine animals. And if you design a net in a way that you want to just scoop up the trash and you won't want to catch any of these marine animals, that is still not possible because most of these plastics will get scooped up, but along with them the marine animals will also get collected in those big huge nets, so we would be hampering their populations by doing that. And some other challenges that we face is that this patch, since it is sufficiently far away from a country, none of the countries, neither Japan nor USA, are taking the blame, or none of them are taking not the blame, not the responsibility. And none of them is providing funding to help clean it up, or none of them is, you know, on a government level, none of them is like providing funding or like personnel, people that would clean up all this mess that have been created in their oceans. So that is one of the challenges, because if there is no funding, how will you clean it up? Obviously India is not going to go and clean up the Pacific Ocean, right? It does not. Again, it's not our responsibility also, because it's not our ocean there. And so, size of the huge ocean, the oceans are huge in size, and the amount of garbage there, that is accumulated there is a lot. It's humongous amounts of plastic waste, and you cannot, even if you do this thing of deploying ships to clean up the garbage, it's gonna take a lot of time. Even after like decades are gonna go by, even if you clean up just 1% of the garbage that's out there. And as I said, many microplastics are the same size as the marine animals, so it does not it's not feasible to use nets for cleaning up. So things to do now then are just preventive measures. What you can do is you can limit the amount of disposable plastic you can use. You can limit the amount of disposable bottles you use. You can start using your own metal bottles or other things. You can take your own bottle, fill it up from the water cooler, drink, don't throw away the bottle and fill it up again. You can reuse those things. Don't use plastic straws, don't use like one time use, don't use disposable material in general. Don't throw away your plastic bags in general. Switch to, say, jute bags or tote bags or cotton, something like that. So all of these things, the tourists that go to those coasts, they should be like aware of the consequences of them trashing the coastal zones. And also people who take like ferry rides into the ocean, or the ships or cruises that go out, they should all be made aware. Making aware is one of the most fundamental things that you can do in order to prevent any sort of unsustainable lifestyle or any sort of pollution or damage. A lot of people don't really care, they're not aware of what's going on, and like they're like, okay fine, I'm just throwing away one bottle, there are already thousands of them out there, what does it matter? So making people aware is one of the very difficult and very important tasks in preventing damage. So you limit the amount of disposable plastics that you use, and you increase your biodegradable resource usage. That is one way that you can prevent uh, furthering the amount of waste that's found there. Another thing is that there are these foundations called the Plastic Pollution Coalition and this Plastic Oceans Foundation. These are the foundations that they have been very actively using social media, and they've also been using direct action campaigns in which they go out themselves and they spread awareness, and also they support the individuals, the manufacturers, and the businesses that are trying to make this transition from disposable plastics to moving on to biodegradable and reusable materials. So, as you would see here, not a lot of adaptive measures can be taken in this area. but preventive measures can be. Even when we talk about oil spills, the adaptive measures can be taken. How you can clean up an oil spill is there. Okay, fine. You can use soaps and detergents to like disperse the oil slick, or you can do other things, collect it, and some ways of getting rid of the oil slick. But it's again not very useful. You can set the oil on fire, and the entire ocean surface will be on fire. But since it is such a huge quantity, the best thing to do is take a preventive measure to prevent it instead of controlling it when it has already happened. Right? Okay, so moving on to what is climate. Now we've moved on to the last lecture of the week, and here we discussed about climate change. So let's start by defining what is climate. Anyone? Would you like to define climate in general terms? Not even, you don't need to give me a proper solid definition, but like, what do you understand by climate?
Long term weather pattern.
Yeah, exactly. A long-term weather pattern. So when you talk about weather, it's a short-term description of how is the temperature, how is the humidity, what is the precipitation, if there's wind or not, things like that. And you're correct, Rajeshi, also that wind's average rainfall temperature in a particular region would be referred to as the climate of that region. So it's the broad composite. If you want to put it in the correct definition terms, it would be the broad composite of the average conditions that a region has or a region faces, and it's measured in terms of like temperature, what is the amount of rainfall or precipitation. If there is snow, then what is the amount of snowfall? What is the situation of the ice cover? How are the winds? What is the humidity? All these things. And since it's not a short term thing like like weather, it's climate, it's averaged over a long period of time, and mostly the classical period that we use for this is 30 years uh, for this, for like categorizing that as climate. Okay, so moving on to what are the different components of a climate system. So there were certain different components that were talked about in the lecture. So what are these different components of the climate system, and how do you think they control climate? Ocean, ice, land, vegetation. Okay, and atmosphere. Right. So you're correct. These are the five climate components of the climate system. And how do you think they affect? So there's ocean, land, atmosphere, vegetation, and ice cover. So how do you think they affect the climate? Like, what does the ocean do to alter or impact the climate? Consequently, what is the role played by land, atmosphere, vegetation? Anyone? Like in general, what do you think? What are some ways in which the ocean uh, impacts the climate? Ocean wind, yeah, okay. So you're talking about the ocean breeze, land breeze. Ocean currents affect wind and rainfall. That is true. So also you would be aware of the famous water cycle. So oceans play a major role in that water cycle, and when there is a lot of um, absorption of ocean water, there is formation of clouds, and then there is rainfall. So that is one way in which they impact the climate. Another way is that they act as carbon sinks. A lot of carbon dioxide gets dissolved in the ocean. So oceans would keep the air a little cooler around them. And if you live close to an ocean, you will mostly not experience a very extreme climate. The weather will be somewhat moderate when it comes to winter climate, and even in summers, because of the land breeze and the ocean breeze. You all might have learned it in high school. In the day, the absorbs a lot of heat, it gets very hot, but the ocean, since the water has a high specific heat, the ocean does not get hot like as fast as the land does. So the land, since the air is hotter, the air rises above, it's light, and then the air from the ocean, it flows towards the land. That's the ocean breeze. And consequently, the same thing happens in the evening. By the evening, now the ocean is warmer and the land cools down faster. The air over the land becomes heavier. The air over the ocean rises above, and from land goes to the ocean. So that is one way in which ocean and lands interact with one another and maintain somewhat constant climate. Vegetation, it regulates temperature. That is correct. Vegetation also regulates temperature because of transpiration. So uh, when transpiration happens, it leads to a cooling effect of the surrounding air. Uh, and how does land altitude resources affect the biodiversity? Okay, land altitude and resource affect the biodiversity. Okay, they affect the biodiversity. We're talking about how do they affect the climate? Like like what is the impact on climate? So how does land impact climate? One way is that if you're in a landlocked area like in northern India, if you're somewhere in Punjab or Haryana or Delhi, you're going to get extremes of climate. You're going to get very cold and very hot climate just because you are in a landlocked area. Then if you have a lot of ice cover, that area is going to be very cold, and a lot of the sunlight is just going to get reflected from there, and you're going to be facing very low temperatures in that area. And even when the sun is out, it's still not going to get very warm. And atmosphere, as we discussed, the wind currents, they control the not just the air temperatures, but also they take clouds with them, and then they control precipitation in that manner. And all of these five components of the climate system, they do not act like just on their own, but they all interact with every other component out there. Like ocean interacts with all of the other four components, and they all together control, or they dictate how the climate is going to be in that particular region, right? So moving on to what we are facing right now is climate change. So can you guys define what is climate change, or how would you define climate change? Anyone, would you like to define what is climate change, or what do we mean by climate change?
Long-term shifts in temperature and weather patterns.
Okay, so a long-term shift in the temperature and other factors. Okay, fine, but a better definition would be when the variability in the climate. So in general, also the climate would be changing, right? It's not like the weather conditions would be changing in an area. So if that change becomes even more pronounced, and when there is a statistically significant variation in this mean state of the climate, or the variability of the climate, that is when you call it climate change. So in general also the climate or the weather in an area would experience some amounts of ups and downs, but that would be within within a range of deviation or of variance. But if the change now is so pronounced and that it is statistically significant, that is when you actually classify it as climate change. And there are factors that affect climate change. There are natural factors and there are external factors. Natural factors are mostly the factors that are because of the earth. There is tectonic plate movement, there is sun, and there is the earth's own other things. And external forcings are mostly the factors that are caused by humans. What are the anthropogenic factors that are leading to climate change? So we've discussed this a lot of the times in a lot of detail, how humans have been impacting climate. We have been increasing the amount of greenhouse gases emissions. If there's a lot of greenhouse gases, they're going to absorb a lot of heat. That's going to lead to global warming. It's leading to rising temperatures. If a lot of temperatures rise, even the ices at the poles are going to melt. If the ice melts, the sea level is going to rise. If the sea level rises, the coastal areas are going to drown. They're going to get submerged in water. And that is a lot of like, there is a lot of things, everything is connected with each other. And that is how climate change is going to impact like everything and everybody on this planet. So moving on to, I'm just gonna like give a few examples of how are birds getting affected by climate change. So migration patterns are getting changed because of climate change. So as you would be aware that birds mostly they migrate when things are getting when the weather is getting very cold in one particular area, and they have to migrate to the warmer regions in order to breed, or in order to for completing the reproductive cycle, right? So, or just they are coming down for resources, because when it's cold the resources have gone down and now they move to the warmer regions in order to like find better resources. So, but what is happening right now is that because summer is coming faster than expected. Earlier, it used to get warmer around April, by mid-April. Now, since the summer is shifting, it's coming earlier each year. So the birds are also migrating uh, earlier than they were supposed to. And what consequences can happen because of this is that, so say you have a resident species of birds that live in an area, and they suppose they have their reproductive period from around February to March. Okay, they lay their eggs and all that, so they occupy a lot of these nest sites. Fine. Say these are species that make their nests in the holes of tree trunks, so they are occupying all these tree trunks. Now there is this migrating species that comes from a colder area and comes to this warm area in order to uh, like lay their eggs and complete their reproductive cycle. But if they are coming in quicker, they are not going to find nesting sites in this new area, because all of the nest holes are occupied by this resident species already. Otherwise, when it used to come later, the nesting species would have already been done with their fledglings, with their young ones being fledged out of the nests, and they would have vacated the nests and these guys would have used them. But now their times are overlapping and they're unable to find nest sites. Something else is that if they come here and they feed on some particular insect larvae, but now since they've come in sooner, maybe the insects have not yet laid their eggs. Maybe they've laid their eggs, but the larvae have not hatched out. So they will not find the resources that they used to find earlier. And so this is how phenology is changing, how the timing of doing things is changing. If they're migrating earlier, if they're reproducing earlier, so certain species out there, they match their reproductive cycle. So a lot of these species in the ecosystems, they are connected, and there are a lot of interspecific relations and there are a lot of prey predator relations. So there are these bird species that mostly lay their eggs in such a way that when their young ones are going to hatch out of the eggs, there are going to be a lot of larvae of their particular prey insect species. So it is easier for them to feed their young ones with these larvae. Okay. Now, if because of climate change, they're either now laying their eggs a little sooner or a little later than expected, then when their eggs hatch, they will not be able to find the same resource because maybe the insect has not yet shifted its own egg laying and hatching process. But if, on the other hand, it could be the same thing, the bird is laying the eggs still on the same time, but the insects are now laying their eggs a little earlier or a little later because of the temperature conditions. So these things that were synchronized earlier are now getting out of sync and they are getting desynchronized from each other. And it it very severely impacts the life cycles of of these particular species, and they might eventually get uh, like they might eventually become extinct because they're not finding resources. Or if you want to take a good a happy ending, they might actually shift to some other resources, and these insects might get new relations or new interactions with some other species of birds which can sync their time with these. So a lot of these things are changing, and a lot of the communities are changing because of climate change. So this is all for today's class. If you guys have any questions or about the lectures, about any of the past quizzes, or about the slideshow, I'm here and you can ask me. And if you guys have no doubts, you can leave the meeting. Thank you for joining. And if you have any questions, I'm here and you can ask me. Anybody has any doubts?
For the exam preparation, like for the MCQs that we are going to take,
Okay.
are these slides enough? Like, it's fine, right? Or should we go through somewhere else, like other study materials or something else?
No, I think for the exam preparation, whatever lecture notes and lecture transcripts they have provided, if you read through them, that should be enough because they have provided, right, the lecture transcripts.
Yeah.
Yeah, so that would be enough, I guess. And if you're interested to know more, you can always Google.
Thank you.
Thank you. Anybody else? Does anybody have doubts? If not, I will end the meeting now. Okay. Thank you all. Thank you for joining.